Hello friends, I'm Snigdha Kakkar and this is my YouTube channel Accelerate AI Careers. So this is the sixth chapter to my complete playlist for generative AI and fourth chapter to my NLP playlist. This is targeted to help you start at a beginner's level, become acquainted with the theoretical as well as practical concepts in this field. We'll also do hands-on project in parallel, so I suggest that you have your Jupyter notebooks open and conduct the entire steps which I do in depth in parallel with me and become an expert. In the last few sessions, we covered tokenization, stemming, and lemmatization. Today's session, we will continue with three text pre-processing concepts, which are stop words, parts of speech, and named entity recognition. We will see what are stop words, why handling them is important. I'll also show you how to do it with the help of an LTK library in our Jupyter notebook. If you really like my lessons, please like this video, subscribe my channel. I'm open to feedback. Provide me your feedback in your comments. Also, if you feel that there is some other essential topic I should prioritize, mention them in the comments. So let's begin our learning journey. So here I have my Jupyter notebook opened for Stopwords with NLTK. I will also upload the GitHub link for all of my Jupyter notebooks here with the YouTube video. Make sure you refer to it and do the project in parallel with me so that you can learn better. It's always better to practice it yourself rather than just seeing it or hearing it from me, because then it helps you ingrain the knowledge. So let's begin it. So I have taken a small paragraph. It's a speech excerpt from engineering colleges by some famous personalities such as Steve Jobs, Bill Gates, Robert De Niro, Shah Rukh Khan, and J.K. Rowling. So this is a small excerpt of that speech. We are going to see what stopwords are. Why do we need to remove them? If we need to remove them, how do we do that? So now, as you can see, there are certain words such as here, are, the, his, certain words which might be part of the sentences to make them full sentences, but might not be that important to further processes we want to do on those paragraphs or those corpus or sentences. So we actually don't need those words. And even if we remove those words, our further processing steps might not suffer. Those words are called stop words. So words such as the, an, of, there, them, etc., which might not play a very important role in any kind of task you want to do with your text, but some of the words such as neither, nor, might have some important role to play. So we basically find those all words which we can remove without impacting any of our future steps. Those are called stop words, and the process is called stop words removal. So how do we go about it? Here, we will be practicing all prior strategies which we have done, such as stemming, lemmatization, as well as tokenization. And then we will be doing stopwords removal. So do it alongside me so that you can follow the steps along. If you fall behind somewhere, pause the video, try doing the steps first, and then continue with the video. So now I'll just import Porter Stemmer from nltk.stem. And I'll also import stopwords from nltk.corpus, and I'll import nltk. You might get some error when you're importing stopwords. The error might be because you have not downloaded stopwords. So just download nltk.download stopwords and it will download the entire corpus for you. Now you can provide a language in the bracket here, stopwords.words, and the language could be English, the language could be French, the language could be Arabic, any language you're looking for, and you will get a list of all the stopwords in that language. So like here I have tried out stopwords in English. So we'll write stopwords.words English, and you get all the list of words there. If you feel that there are certain words in it which you want in your data, and whereas there are certain which are not here, which you don't want in your data, then you can create your own list of stopwords. Similarly, I have done stopwords.words for French, and same way you can do stopwords.words for Arabic. So now I have imported my Porter Stemmer. I will instantiate it. Stemmer equals to Porter Stemmer. Then I will also tokenize my sentences. So my speech is currently in the form of a corpus or a paragraph. I will sentence tokenize it using a sent tokenize. If you want to know more about tokenization, please watch my video on tokenization. Same for stemming and lemmatization. If you want to know and learn more about stemming techniques and lemmatization, which is better, which is not good, which is time consuming, please refer to my prior video on stemming and lemmatization. So you do send tokenize here. And once you send tokenize, that means it will convert your entire paragraph, break it down into sentences as shown here. I have displayed it here. So you can see that a list of sentences has been formed. And you can see nothing else has changed, just the paragraph got broken down into sentences. And if you check the type of this variable sentences, you would see it's a list variable. Now we need to apply stopwords removal techniques followed by stemming. Run for I in range of length of sentences. For the entire list of sentences, I will run this loop and I will do a word tokenization of all those sentences. So basically, it will tokenize those sentences and break it down into words. For that, I'm using word tokenize from NLTK library again. Once the words have been tokenized, they get saved in a variable called words. Then I conduct stemming. What stemming does is it reduces the main word to its root word, which might make sense, which might not make sense. So I'm doing list comprehension here and I'm doing stemmer.stem word. Basically the stemmer which you initialized here, this stemmer is being called here and it's being called on the word. So stemmer.stem word for each word, if word is not in set of stopwords dot words of English. So basically stem only those words which are not in the list of stopwords. If they are in the list of stopwords, leave them as such. And then you save it in your words variable again. So you overwrite it. And then in sentences, you are just joining all those words with space. So basically you are converting all the list of words you got in step 2 after stemming and removing the stop words, and you are joining them using the space and getting your sentences again. And if you print now sentences, you would see our word is removed here and all words have been reduced to their root words, such as graduate has been reduced to graduate. It doesn't make sense here, but that's how it has been reduced to their stem words. So here, popular, graduate, speech, celebrities has been reduced to celebra. Again, a bad stemming example here. But you understand, right? We first converted paragraphs into sentences using sentence tokenizer. After tokenizing the sentences, we ran a for loop for the range of length of sentences. We tokenized those sentences to convert them into words. And then we did a list comprehension for all the words and did the stemming for only those words which were not in the set of stop words for words in English. That ways we got all stop words removed. And then we joined all those words with the joiner of space in the variable sentences so that you have all the words joined in the form of sentences with the removal of stop words. So this is your result, but I'm not satisfied with it. As you can see, most of the words do not make sense. They have been reduced to stem, but they are not meaningful anymore. So we will improve them. In the previous video, I told you Snowball stemmer works better than Porter's stemmer. So let's try using it. Prior to that, I would like to point out here, if you can see, all capital letters have also been reduced to their small letters. So everything is in lowercase now, nothing is in uppercase. So Porter's stemmer also reduces that. Now, when we are using Snowball stemmer, I'm instantializing Snowball stemmer here. So I will pass language English for stemmer and I will instantiate Snowball stemmer. And then I will copy my function from the top again, but instead of using stemmer here, I will be using Snowball stemmer. So I will run it for range in length of sentences. And then I will word tokenize those sentences. And then I will use snowball stemmer.stem in my list comprehension for all the words, the words which are not there in stopword set. And then I'll join them using the space in sentences. And let's display it and see how it looks. So here you can see it's still doing a better job, but far from satisfactory, right? You can see so many words being reduced to their root, which does not make sense, such as celebrities has been reduced to celebra, audience has been reduced to audience here, universe has been reduced to universe. So all these things need to be corrected. So what's the strategy? Instead of stemming, let's try out lemmatization. So for using lemmatization, I will import WordNet Lemmatizer from nltk.stem. I have talked more about it in my stemming and lemmatization video. Do watch it. Lemmatizer, I will instantiate it. So WordNet Lemmatizer That's how we instantiate it. And then again, I'll copy the above function. I forgot to mention one thing. Since you are again and again overwriting sentences here, so before running the function again, you would need to run this cell where you are doing, you would need to run this cell where you are running the paragraph to sentence conversion, which is sentence tokenization. So let me take you to that place. One second. Yeah, this cell number 37, you need to run it again every time you are running that for loop because you are overwriting your sentences variable. So you might get error otherwise because this variable has been overwritten. So to avoid it, either use a different variable here, or if you're using the same variable, then rerun the sentence tokenization first. Okay. So now we will run the for loop for coordinate lematizer. So instead of stemmer here in third row, we will use lematizer.lematize for each word, and we will provide the pause tag as verb because that gives the best results, and we'll do list comprehension for all the words which are not there in the set of stop words. So, and then we will join all those words in a sentence using space and see how it looks. So, do you see here popular graduation speeches, celebrities, mesmerize audience? So, all stop words have been removed and the words which are retained are meaningful. They are not meaningless. But do you see that there are upper caps and lower caps here? Lemmatization doesn't deal with it. Lemmatization doesn't lowercase everything automatically. So, to lowercase them, you have to use word dot lower here. So, we will do tokenization using word tokenize. Then we'll do list comprehension and apply lematizer.lematize. But before applying, we will do word.lower. That way, all words will be turned into lowercase. Then we apply pause tag as verb and do list comprehension for all those words which are not there in the set of stop words English. And then we run it after joining the words in sentence by spaces. And you see everything is being joined and combined to lowercase. So that's how stopwords removal works, and I hope you have practiced it alongside me. If not, pause the video now, try it out. If you face any issues, please mention them in the comments of the video. I'll make a follow-up video to explain it better. Okay, so the next topic which we are going to look at is parts of speech. So the next topic which I'm going to talk about is parts of speech tagging. Why is it important to know about it first? So you used lemmatization techniques in the last video as well as just now when you were checking for lemmatization. At that time, you use post tags such as noun, verb, adverb, but you might be wondering what other post tags are there which I can use. So that is one place where you can use tagging. The other places will be in future for text pre-processing steps. So you should know what kind of tagging is possible. So these are certain options available, but I'll first tell you the example. So I have one sentence: Disneyland is full of fun and fervor. It is an amazing place for kids. So here Disneyland is a proper noun, and is a conjunction, of is a preposition, is a verb, amazing is an adjective, place is a noun, kids is a noun again, but a plural noun. So it is a pronoun. So this way, your sentence, each word can be segmented into one or the other kind of tag. So these are the tags available, like CC stands for coordinating conjunction, CD stands for cardinal digit, JJ stands for large adjective, JJR stands for comparative adjective, JJS stands for superlative adjective, NN stands for noun, singular, NNS stands for plural noun, NNP stands for proper noun, singular, NNPS stands for plural noun, proper noun. So same way, you can go through the list. I will upload this sheet, this Jupyter notebook on GitHub and share the GitHub link alongside video. Please refer to it, use it to do the work in parallel. So we will continue with the same example we used, an excerpt of speeches in engineering colleges by some famous personalities. And we'll continue with the same example here. So I have instantiated the speech variable. Now I will break down this excerpt into sentences by using send tokenize. So I have done it here. And then I'll just list out all the sentences I got. So it's a list of sentences. Now for using tagging, we first need to download averaged perceptron tagger. If you do not download it, you will run into errors. So first download that. Then you should also conduct stopwords removal before you are doing tagging. So I'll import stopwords from nltk.corpus, and then I'll run my for loop from I in range of length of sentences. And I'll first do word tokenization for sentences. So I'll use word tokenize to do that. Then I'll formulate a list comprehension where I'll run for each word, but I'll not run it for stopwords. So I'll remove those words which are in the set of stopwords English, and I'll overwrite it in the same variable words. And then for tagging, I will use nltk.postTag, and I'll run it. And when I print it, you can see for each word, you have one tag. Like popular is an adjective, so the tag is JJ. Graduation is a noun, so the tag is NN. Speeches is a plural noun, so the tag is NNS. Same for celebrities. Same way, you can see your each word of your sentence has been given a tag. Now, this is about text which you entered yourself in the form of sentences or corpus. What about some text which is available in NLTK library or NLTK corpus? So to handle it, you can implement this way. From nltk.corpus, I import Brown. Brown is a dataset. But first, to import it, I need to download it. So I've downloaded it here. And then I apply dot tagged sends. And then I just print it out. And you can see that each element has been post tagged. You can go through and see the tags here. Now, Disneyland is an amazing place for kids was a sentence I initially introduced. I'll just split it. So a list of words has been generated after splitting, and I will pass it through nltk.postTag. And you can see the tags have been allocated for each word. So now you know how to do stemming, lemmatization, how to do sentence tokenization, word tokenization. You also know how to remove stop words. And finally, you now know how to apply post tagging for any kind of text. So I hope that clarifies. We'll move to the next step, which is named entity recognition. If you have any questions, please mention them in the comments. I will address it in the next video. Let's look at named entity recognition now. I have taken a sentence here. The Taj Mahal is an ivory white marble mausoleum on the south bank of the Yamuna River in the Indian city of Agra. It was commissioned in 1632 by the Mughal Emperor Shah Jahan, reigned from 1628 to 1658, to house the tomb of his favorite wife Mumtaz Mahal. Now, you can see there are so many entities here. What do you mean by named entities actually? So such as Taj Mahal, Shah Jahan, Yamuna, Agra, even Mumtaz Mahal. All these are entities. So, for example, a person entity could be Snigdha Gakkad, a place entity could be India, date entity could be today's date, time could be 9:30 a.m., money entity could be 100K, organizations could be Amazon, IBM, Stratfor, Accelerate AI Careers, and so on. Percent entities could be 30%, 0.5%. So, we will work with these sentences and generate entities or recognize entities from these. So I take the sentence excerpt from here, the Taj Mahal excerpt, and I save it in a sentence variable. After that, I import an NTK library and I do word tokenization for this sentence. And when I do word tokenization, I save it in the variable words. So I'll just print out the words variable here, and you can see it's a list of all the words comprised in that sentence. I have not removed any stop words, so as it is. And after that, I do post tagging. So for doing post tagging, I'm just applying nltk.postTag, and everything gets saved in tag words. So if I generate tag words, you can see each word has a tag associated with it. After that, for doing any kind of named entity chunking, I first need to download max_ne_chunker. Otherwise, you will get errors. And you also need to download nltk.download words. So please run these two cells prior to running any kind of named entity chunking. Once you have done them successfully, after that, you can run nltk.ne_chunk, that is named entity chunking of the tagged words. That way, the chunking would happen. And if you want to see that chunking in the form of a diagram, then you can run .draw, and you will get this kind of diagram in a separate window. I have posted the image of the diagram here, but for you, if you apply this and run the cell, a separate window will open where the diagram will open. And you can see for organization, it does the tagging like Taj is a NNP, that is a proper noun. Mahal is a proper noun. Then GPE, that Yamuna has been given a proper noun. Indian is JJ, that is adjective. Agra is again a proper noun. So that means it does the post tagging and then it chunks the entities based on those tagging. So I hope that clarifies what an entity is. How do you do named entity chunking? How does post tagging help in that kind of chunking? For next, there are so many steps you can do in named entity recognition itself, even using large language models. So we will do it, but step by step. For now, you should know how to do named entity chunking. If you have any questions, please post them in the comments. I will share these notebooks in the GitHub.